Now we go to few more groups of few more functional groups in the area of organic chemistry. Another group of important compounds are amines. Amines are basic in nature. Organic amines are basic in nature. As a base, as a rule, they are all soluble. If a compound is soluble in hydrochloric acid, then it indicates the presence of a basic nature in the organic compound. So, solubility in dilute HCl is a sure test for testing the basicity or the basic nature of the compound. So, solubility in dilute HCl is one of the tests for the amine. It dissolves in HCl, and the dissolved substance can be regenerated by the addition of sodium hydroxide. So, solubility in HCl, and on alkalification or the addition of alkali, it gets regenerated, is one of the tests for just to indicate whether an amine is present or not. Amines can be of three different types: primary, secondary and tertiary amines. A primary amine is one which contains an NH2 group. A secondary amine is one which contains an NH group. A primary amine is one which contains an NH2. A secondary amine which contains an NH group, and a tertiary amine is one which contains only an N to which three different groups. So, this group is present, it is a tertiary amine. This is a secondary amine and this is a primary amine. So, there is a very important test for an aromatic primary amine, or a very important test for any primary amine, which is known as a carbylamine reaction. A primary amine on treatment with chloroform and a strong base like sodium hydroxide or potassium hydroxide will produce a substance which is known as alkyl or aryl isocyanide, RNC, foul smelling isocyanide. This is known as a carbylamine. This is known as a carbylamine reaction. A primary amine gives a carbylamine reaction with chloroform and alkali. And the carbylamine can easily be identified by a very strong and a foul smelling nature. It is a very bad smell it has, and therefore it is identified by the foul smelling formation of foul smelling carbylamine. Then it indicates the presence of a primary amine. This is one of the very important tests for the indicating the presence of a primary amine. The primary amine, secondary amines and tertiary amine can be distinguished by means of a reagent which is known as Hinsberg reagent. This Hinsberg reagent is either benzene sulfonyl chloride or toluene. A methyl group will be attached to this. Benzene sulfonyl chloride or toluene sulfonyl chloride. When this Hinsberg reagent, which is benzene sulfonyl chloride or toluene sulfonyl chloride, is reacted with the primary amine, this will form a derivative which will be soluble in sodium hydroxide. It will form a derivative. Benzene sulfonyl amide will be formed, there will be an NH and sodium hydroxide is added, the derivative will dissolve. In that case, it is a primary amine. In the case of the secondary amine, it will react to the Hinsberg reagent or benzene, either benzene sulfonyl chloride or toluene sulfonyl chloride, and forms a derivative, but it will be insoluble in sodium hydroxide. Solubility in sodium hydroxide, in the case of the primary amine, it will be insoluble in sodium hydroxide, it will form a derivative with the secondary amine, but it will be insoluble in sodium hydroxide. But in the case of the tertiary amine, this reagent, Hinsberg's reagent, will not react with the tertiary amine. Primary amine will react with benzene sulfonyl chloride to form a derivative soluble in sodium hydroxide. It will form a derivative but does not dissolve in sodium hydroxide and does not react at all with tertiary amine. This is one of the methods of distinguishing between a primary amine, secondary amine and tertiary amine. Now, we go to the next group of compounds which are known as amides. Amides are neutral in nature. Amides contain the functional group CONH2. When this group is present, this is known as a primary amide. This all primary amides on reaction with sodium hydroxide will liberate ammonia. One of the tests for the amide is when the amide is sodium hydroxide is added to the solution and boiled, it will liberate ammonia. When ammonia is liberated on addition of sodium hydroxide in boiling, it indicates the presence of a functional group like CONH2, which is a primary amide. Supposing CH3 is attached, it is known as acetamide. Supposing a benzene ring is attached, it is known as benzamide. So, benzamide on boiling with this will give ammonia and the sodium salt of benzoic acid. Acetamide on treatment with sodium hydroxide will liberate ammonia, forming the sodium salt of acetic acid. So ammonia will be liberated and the sodium salt of the corresponding carboxylic acid will be produced in the case of the primary amides. So primary amides will liberate ammonia on treatment with sodium hydroxide solution. Another functional group which you would like to discuss here is the nitro group. As for example, nitrobenzene, a compound containing, this is nitrobenzene, and a compound containing a nitro group, this indicates the presence of a nitro group. And this nitrobenzene, how will you detect the presence of the nitro group in nitrobenzene? This is done by means of a reaction, this is affected by means of a reaction which is known as Mulliken and Barker's reaction or Mulliken and Barker's test. What is this test? It is actually the nitro compound is reduced in neutral medium. Normally, the reduction can, supposing it is zinc and hydrochloric acid, it is acid medium. It is zinc and sodium hydroxide, it is alkaline medium. But it is neither acidic nor alkaline, this is the neutral medium. So, when this compound, a nitro compound, is treated with zinc and hydrochloric acid, this nitro group is reduced to phenyl hydroxylamine. NO2 does not become NH2. NO2 becomes C6H5 NHOH. This NO2 becomes NHOH. When this is after treatment with boiling with zinc and ammonium chloride, it is filtered and the filtrate is treated with the tolerance reagent. You know what is meant by tolerance reagent? We have studied at the case of aldehydes and ketones. It is ammoniacal silver nitrate solution. You will get a black precipitate. If a black precipitate is obtained, if a nitro compound is taken, treated, reduced in neutral medium by means of zinc and ammonium chloride, and the filtrate is treated with tolerance reagent, and if a black precipitate is obtained, it shows the presence of a nitro compound in the given organic substrate. This is referred as, this is known as the Mulliken and Barker's test for one of the important tests for identifying the presence of the nitro group in the given organic compound.